or application layer. Okay, so in application layer, so it is very simple. Application base, so at a client side and as well as a server side application, working, not working, service running. Okay, and also understanding protocols. Based on the protocols, it understand what is user request. Okay, so based on the protocol, what is a user request. For example, simple example I will tell. For example, you have a doubt in the technical doubt is there. You can ask me or you can ask Madhu sir, right? Or a Sai Prasad sir, you can ask. If you have a question about fees, or maybe a question about a next drive, you have to ask Pavni madam or maybe Saiti about it, right? Like that. Charan sir, right? So yeah, you can ask technical question to Charan sir also, but usually we are a trainer, so then like that. So to whom you are asking and what you are asking. So what is your request? We should understand by the protocol. Means we put a subject line, right? So this is a request for this one. We need a technical notes, right? Like that. Okay. So here is a protocol. We have to protocol means very simple to understand. It is set of rules. So what is that rules? Earlier when I was in a college days, school days, usually college days, people tell an example when lecturers came to room, you have to stand up, you have to salute the police like that. That is protocols. No, it is not a, that is different protocols. Okay, so we should not generalize one to another one sometimes. But here is a protocol. Here it is. To whom you are asking and what you are asking. So you are asking a web server about a web page. So web server understand your request is HTTP, so then it will provide a web page related. For a web page, you are requesting for mail communication. It don't have any mail related services. It drop the packet simply, right? So service and protocols. When you are transferring a data, so you said HTTP, but system don't send HTTP. It will send port numbers only, because port numbers, it is a in a digital format, and these port numbers are hexa format mainly. Okay, easy to convert hexa, so binary. So what these port numbers is a number wise, it will convert into ASCII format, and it will easily sent to the destination and destination to source again. So this is about your application layer anyway. Next one is presentation layer. So what is this presentation layer? Presentation layer having three duties mainly. So your data, so while you are transferring a data, your data can be in any format. It can be a text format, it can be a picture format. So for example, if you see, these are all text formats, but this is the a wave format
Involve.
is, right?
Involve.
So wave format. If for example, if I click on an image, so different type of format, there is a pictures, gifs, links, okay, text, different type of formats of data can be there. The format can be a text or maybe a PDF or DOCs, okay, text based formats, or maybe a HTML. Okay, HTML formats are there, JavaScript formats are there, like so usually anything is HTML format only. Okay, HTML format can be there, or maybe FLV. Earlier days we use FLV, MP4, video formats, GIF, PNG, JPG, picture formats. Okay, so data can be any format, but that the format can be converted into ASCII. What is ASCII? MKV format, Very good. ABC, WMVA, wave, shock wave, like different formats are there. Okay. What is ASCII? American Standard Code for, yeah, very good. Information interchange. Okay. Information interchange. So what is this exactly? The word we know. What is exactly? You have a different type of data is there, like letters A B C D kind of stuff, or can be one two three kind of stuff, or it can be a dot, comma, semicolon, or a brackets, anything plus or equal to whatever it is. The equivalent, the equivalent, a hexadecimal number will be there. There is a number will be there for everything, for every character. This is a high level language. We can understand high level language, abcds, 1 2 3 4 symbols, icons like this we can understand, but computer cannot understand that one. So what it will do, it will convert into the ASCII format. For everything there is a value like 23, 25, or maybe 30, 31, 32. Like everything as proper ASCII value is there. Why this ASCII value? It is directly X code format. It is easily converted into binary for a machine understanding language. Okay, it is quite easy to convert your ASCII to binary format. So that's why it is um, American Standard Code for Information Interchange. They put that number in that one. Okay. So it converts whatever the data you're sending or receiving. So while sending, so whatever the data it is, convert into ASCII format. Next, it compress the data. Compression, decompression of data is there. So your data may be like a video, a picture, text, or anything. It is a big in size. It compress the data and send. And when it is received, it decompress the data. Okay. And very important, another important one is encrypt. De-encrypt the data. Decrypt. Sorry. Okay. uh, decrypt the data. For example, I'm using HTTPS. HTTPS means over SSL. It means it encrypt your data when it is transferring the data, and when it is received, so we decrypt it and we see the data. So whenever I sending any data from here, so you can see HTTPS will be there. You can see here HTTPS. It means it encrypt the data while you are sending it. When you are receiving it, it will decrypt the data. Okay, it will decrypt the data when you are receiving it. So that's a part of your presentation layer. So next one is session layer. Okay, session layer, you can put it. Session layer means when I open a site. So when I, just for example, we know websites better way than any other things. Okay, so when you are sending or you are pinging, or maybe you are open a website, or maybe you are transferring a data. So when you are initiating, like just you are open. Okay, when you are open, so automatically session will be created. Okay, so your request is sent, right? And at receiving end, means in destination it receives your request, and based on your request it will forward the information, it will send a response to you. So it will send a data to your system, right? So that is till the time means you are created you are sending request and you received complete data. Till the part completed, it maintain the session. So when you are open, when you are start sending a request or sending a data, so it is created a session. It maintain the session. And once it is completed, it will terminate the session. Okay. So it will create a session, maintain the session, and terminate the session. And also it will maintain multi sessions also. It means sometimes a session contains a multiple sessions also there. So it will also can able to handle the multi session types requests also. Even at as a destination side, so whenever it is receive a request and forwarding, so when it is received, it will create a session, and once it is forward entire data communication is completed, till the time it will maintain the session. Once it is completed, it terminate the session. In generally, yeah, it is responsible for connection. Okay, so it will create a connection. So when you are start a session, it will maintain till the connection is completed or completely terminated or closed. Sometimes this session also having a timeline. So like if you open a certain web page, it maintain the web page like that only without any refresh. 5 to 10 minutes the web page is open and you are not doing anything, just you log in and you are not doing anything, it automatically terminate the session after 5 to 10 minutes. Yeah, the thing is called a timed out. So every certain sessions are having a auto timed out sessions are there, like a 90 seconds, 180 seconds, or 60 seconds. If you are not doing anything, just you are not completing that process, or just you left there and you are not filling the form like that, or maybe just you log in and you are not doing anything, automatically session will be expires. These are the terminology: session expires, or a session time out. Okay, time out is also there. So like particular time period is will be there. And if you open a Gmail account, for example, Gmail, or like this kind of websites, YouTube's, okay, why it is not timed out? Why certain websites are timed out? Because when they create it, so they put a this thing is like in a particular time period, it should be expire for a security reasons, like a banking transactions. Bank transactions are very dangerous, right? You keep it and leave it, someone will send your money to their own account. Okay, so that's why they put a expiry time for a e-session. Passport websites, so they put a session timed outs. Certain websites don't have they have a expiry, but it is a reloading expiry type, means after 120 seconds, for example, after 120, every 120 second refresh, it means refresh their page. So, for example, I open my Gmail account or a W3 schools, or maybe I open this one. So, it will take time. In a certain particular period of time, the session will be automatically gone, but it will maintain to maintain the session till keep refreshing user page. Then you will get a new updated data, like a mainly Gmail account. You can see that one. Okay. Just for example, I given refresh kind of stuff. Um, I don't know whether we have a time or not. We don't have a time. But I want to tell one. Actually, I have one beautiful example, really to understand what I done when I got a job in Pune in our Vedic Soft. So I came to Pune two times, but that is finally I got my appointment letter, and I from Hyderabad office. I took it from Hyderabad office. I have to join in here. Okay, so I didn't book the ticket because till the letter I not confirmed to go to the Pune or not. I don't know. So then finally I want to start on Sunday. So Saturday I open a Tatkal book ticketing. Tatkal. Okay. Tatkal AC starts at 10 o'clock, right? So 10 o'clock. So exactly I open. I am giving all the information within less than a minute only. Just I given every information is ready. Mobile phone, right? So information is ready. I connected to Wi-Fi. Okay. Important is not a story. Connection is important. Remember that connection. So I use my Wi-Fi. Okay. So through Wi-Fi means I have a ACT internet connection is there. So Wi-Fi, through Wi-Fi I'm getting internet, right? So I am getting internet through Wi-Fi. Through Wi-Fi only I've opened my IRCTC website, and I fill the form. Okay, and I went to payment. So exactly at the time of payment, okay, when I giving the payment information, power cut. Power cut means Wi-Fi off, internet is gone. Wi-Fi off, internet is gone. But it is a mobile, right? What happens if Wi-Fi is off? Automatically it switches to 4G. Yes, 4G data automatically it switch. So I think it is the app is open and it is everything is going on. When it is switching, while I'm typing a payment kind of stuff, and it is failed. I type and I click OK. Session is going on, power cut, and it switched to 4G. Session is expired automatically. And I'm trying doing again. So I'm trying to pay again. It's not happening. So what I've done, again I close entire IRCTC, open IRCTC again. Then of course tickets are gone, completed. No second AC, no third AC. So all are, it is that to Saturday Sunday it is difficult, right? So obviously, so I book a ticket at 11 o'clock. Okay, so 11 o'clock. Um, Timer. So that to power cut is 5 to 10 minutes only, just not even a 5 minutes. Just power cut, turn into the 4G. Meanwhile, meanwhile the power is also came in 2 minutes max. Just power cut in exactly 10 o'clock. So what happened here? Problem is occurs because problem. Why I got a problem? This is a created session internet through this Wi-Fi. So this is a secure one secure channel it will create. So it encrypt the session like this. It maintain the session for entire transmission. When it is failure, it is a different network. When it is failure, it is a different network. So it is not okay with some random network. Here it is not from the starting to ending. If I start with the 4G, then I can complete with the 4G. But when I use a Wi-Fi, so and switching to 4G, it won't work. So this is the one of I got an experience. From that day onwards, almost so many times I switch to 4G, and then only I do my all my reservations. Usually like um, reserve tatkal kind of stuff. Okay. So session layer will maintain, terminate, create a session. For it. Even one more example is there. General example. For example, if I want to download some data from here, Okay, maybe it is a um, I'm downloading 10 MB data. Okay, 10 MB data. I'm downloading a file. Data means okay. I'm downloading 10 MB file. 5 MB downloaded. Okay, 9 MB downloaded. Internet is gone. Network is down. Power cut or maybe cable loose. Just for 15 to 20 seconds only. What happened? Session wait for a 15 to 20 minutes. Actually, generally it is wait for a 15 seconds. Any disturb occurs within a 15 second, it is okay. More than 15 seconds, uh, network connection is lost. Automatically, it will terminate the session. So what you have to do? Download again, right? Normally, so you are trying to download a 10 MB, you are transferring 10 MB data. So at 9 MB, almost reach 90%. Then small disturbances occur. So like a off minute is occur. So session is expired automatically. You can't able to download remaining one. You have to do it from starting. Download it again from start. Right, guys. For examples only, I'm writing. I'm not giving entire text kind of stuff. So you have to understand and remember that. Just that's why I given some symbols. So then next time if you see, you can easily recollect it. Things should be in your brain, not in a notes, not in a videos. Okay. Otherwise, why should I create so many videos? Okay, 10 MB, 9 MB volume. For example, I want to download and okay, 10 GB data. Big file, right? Now 10 MB, 9 MB, 10 GB. I downloaded, for example, 4 GB data downloaded. Now power gone, internet is gone. Now I don't want to download it from starting. I want to download remaining 6 GB only. What to do? Any ideas? Understand question? 10 GB data. I downloaded 4 GB and then power cut. Okay. After power cut, again I want to start the download, not from the starting, remaining download only. If in this case, so what we have to do before or after? Pause the download. Okay. Sometimes directly here pause downloads. Before you click on a pause download, what happen? It will expires. You may not get a chance to pause also sometimes. We should use download managers. Okay, like mobile also use e-browser kind of stuff like this one. Download managers content browsers are there, or you have to use different type of applications also like a FDM, free download manager, IDM, internet download manager, this kind of stuff. Usually I use FDM to download anything. Okay, so your 10 GB, I'm down. It keep 4 GB data downloaded. Internet is gone. After once internet is came, it continue after 4 GB only. So how it is possible? It save the session. So it check how much data is downloaded and it will save the session and what it will do, it re-establish the previous session. It will re-establish the previous session, so then download will continuous. It's not like a new session is created, it is like a continuing the old session only. So re-establish the old session. That is a technique in the download managers. Yes, for example, your Windows 10 is around 4 GB, right? Windows Server This is around 5 GB. 16 or a 19 around a 5 GB. Okay, like if you have a very big files to download and you are using mobile data, or maybe no guarantee internets, right? Suddenly power cuts, like possibility is there. Sometimes internet lost. Now internet is also frequently disconnecting. Okay, so better to use a free download manager or a IDM. Which one is your favorite? You can use it. I'm using free download manager. Okay, I download any files with a FDM only. Why? Because of there is no guarantee your internet is continuously available. Okay, so it is also like you can download one by one, like your torrents also same thing. Torrent concept is also, it contains both download manager plus torrent. Enough of informations, so we'll go to transport. Transport is a very big one, but we'll go to the main, all are important only, but compulsory important one. Okay, transport layer. What is this transport layer? It is a heart of OSA layer, end to end connectivity. It is already given, right? Right. So transport layer. What is this transport layer will do? You have a data. Okay, it cut the data into small parts because data is bigger, so then it is very difficult to send it. We are already compressed, but still it is a bigger. Okay, so cut into the small parts or small pieces. Okay, so that we call it as a segment. Okay, that part we call it as a segment. So you have a data, cut the data into small parts. Each part we call it as a segment. Okay, each part we call it as a segment, or we can say this process we call it as a segmenting. Yeah, here it is there. We'll see. I'm going to write a text here. So this is my standard example. Hello, how are you? So this is a simple message, right? So it contains four parts only. So I'll remove this one for making little bit separate one. Okay, this is my message. Hello, how are you? While I'm transmitting a data, so I transmit the data. Data is received at and what happened? Some data part is missing. Then at receiving end, verify the data and data is corrupted. It drop the packet. Okay, it drop the packet. Receiving end, drop the packet. So my source side means my I'm sending, right. Sending side. I thought it is not received because I didn't receive any acknowledgement. Got the point? So here, guys, understand the technique is this is a sender. I'll take another example like a PCA, easy ways, PCB. So we won't confuse who is sending, who is receiving. So PCA send a packet, okay, packet one packet, for example. PCB received a packet. When PCB received a packet, it sent an acknowledgement to PCA. I received a packet. So then PCA knows PCB received a packet. Okay, remember this point, because the acknowledgement is very important here. So how we know the destination received a packet? Because destination will send an acknowledgement to us, so then we know um, destination received a packet. Now data is corrupted, our destination dropped the packet, and we didn't receive any acknowledgement. So obviously PCA will send another packet, send it again, send it again. Okay, now what happened? This time data is received like this only, RU. Again data is corrupted, this is my full data, but I am getting this data at destination. So destination PC drop the packet, and it didn't send any acknowledgement. I wait for an acknowledgement, so acknowledgement not received, again I will send. Now destination side, hello, you only received. Hello, how? Very simple, better is like this. And these two are not there, again corrupted. Okay, again it is corrupted like that. So RU is not received, data is corrupted like this. So if you understand, in case like if you look at my house also, you can don't look at, it is very dirty. I have a one board with a stand. Okay, my sister purchased for putting some sample groceries 3 years back. One container kind of stuff is there, like we can put some groceries in, like some thing is there, and one plastic cardboard is there. Now I purchase another stand for my groceries putting into the places, and this is another for a clothes purpose. So we have a lot of clothes, so then I took a cloth. I received all these things in a disassemble. So every part I received, but they are separated. Okay, I assembled it in my home. If in case this big stand came to my home directly, so then what happened? Wardrobe, for example, pepper fry. It is going to the pepper fry. Okay, whatever it is, we need a picture. See, these are all less separate parts only. Not, my model is not this one. I'm not that much costly, and I don't invest money on costly things. Okay, see, these are all, when you want to purchase these things, everything comes in a separate parts only. Okay, so the guy will come and assemble here. You tell me. Okay, carrying as a single unit, it is very difficult. So then there are put in a separate parts, they send it. Okay, so this is very simple to understand. Segmenting. So I am removing this, I'm keeping this for now. Okay, so here I am writing here. So look at this one. What I'm going to do is I'm going to separate this data. It means I chop the data into small parts, and I put a some numbering on it. Like for example, just for an example, this is not true, but for understanding, so I'm chopping. So how it is happening here there, so we don't mind about it, but it put a numbering on it, and in a sequence format. Now each one I will send it. I will send this packet first. I will send this packet. I will send this packet. I will send this packet. At receiving end, I'm writing about receiving end. First, I received a hello, one packet. Then it will send an acknowledgement. Yeah, I received a packet. Then I received a how. and I received U. Okay, so it send a packet like acknowledgement 1, acknowledgement 2, acknowledgement 4. So what I understand from my acknowledgement, PCA, what it understand from acknowledgement, I send all packets, PCA send all packets, but receive acknowledgement for 1, 2, 4 only. And what it is understand? What it understand? PCA, what is understand? PCB received 1, 2, 4, but not 3. So it is not received ARE. Okay, it is not received ARE. So understand by A, and it will send only that packet only it will send. Now the format is like this. So I have a packet. Hello, how you are. Okay. Now if you are sending and your girlfriend is a English teacher, then it is a breakup day. Yeah, grammatically you are mistaken. Okay. English medium candidate, then it is. Yes, he will follow guarantee. Gazan. So when you want a breakup, send a clean, good message with a mistake. Good ideas, right? Okay. So what happened because of this one problem? Yeah, because of this one problem, right? Again, it will sequence the data. So this is the one, this is two, four, three. It rearrange the data in the proper format like this. It can rearrange. Why? Because how? Because how it is possible? Because of sequencing one. So that is a main part of the transport layer. First part of transport layer is it segment the data. It will do segmenting and numbering and sequencing. It put each segment there is a numbering and sequencing format. So any sequence is interchange, no problem. So at a destination, it can rearrange the data properly. And also we know because of small parts, we know any a particular part of data is missing, we can resend that one only instead of sending same data again and again and fail. So better to send small parts only. Okay, so this is the one of the thing. Of course there is a certain rules are there. So it is around 1600 bytes max size of each segment. Actually it is also wrong because it is a very less than that one. It is around 500 bytes. It is around 500 bytes only. Sorry, 1534 something around bytes only. Okay, you can see there is a what is the maximum value of MTU. Maximum transmitted unit is a 1600 bytes generally. MTU, what is maximum transmitted unit? Each unit size is so 1600 bytes. So obviously your segment is less than 1600. Okay, so you can go to any adapter like that or router properties also. You can see this is the one single packet, whole packet size. Okay, still we are not adding other information also, we have to add it. So your packet size, so not less than 64 bytes, should not be less than 64 bytes. If it is a less than 64 byte, it is called as a chunk. Okay, it is waste, small pieces less than 64 bytes is a chunk. Okay, maximum transmitted unit, transmission unit or anything. Otherwise, you can search it. Okay, so this is the one part, and another very important part is it multiplex and multiplex your ports or protocols into TCP and UDP. Okay, so what is this TCP UDP? Um, what is this TCP and UDP? TCP means transmission control protocol. Okay, TCP properties are different. Okay, so then UDP properties are a little bit different. UDP means user datagram protocol. Okay, user datagram protocol. Why always in a OSI layers? So TCP UDP differences will come up because it's a very simple thing is TCP is a kind of reliable TCP mechanism and UDP mechanism. Okay, so usually TCP mechanism explanation is there, like a sync, acknowledge sync, and sync acknowledgement type of thing is there. So I'm not going to explain complete mechanism. So like what I draw here, like this only I will explain. Okay, so it is a acknowledgement based transmission. So TCP first I will tell a explanation. This is the PC1 and this is the PC2, or you can take PCA, PCB kind of stuff also. So I'm sending a packet and it receive a packet. Okay, I send a packet, it received a packet. I send a packet. So PC2 received a packet. So what it will do, it send an acknowledgement to the destination. The destination understand. So okay, PC2 received my packet. Then it will send another packet. Then it will send another packet. So acknowledgement to received packet. So then, for example, another packet, just at least minimum three packets, three, and here I didn't receive anything. Okay, so obviously my PC1 and think PC2 not received my third packet, so it will send the packet again. Okay, now my PC2 received it, so it will send acknowledgement. Otherwise, it will send it again. Okay, so this is a acknowledgement based communication. Because of that, it is called a reliable. It is called a reliable data transmission, reliable protocol. Okay, so it is a reliable connection ori connection oriented protocol. It is a connection oriented protocol. Okay, it is a reliable connection oriented protocol. Next, so we'll go to the UDP. Same PC 1 and PC 2. Same thing here it is. Packet I am sending and it received a packet. And packet here I am sending it received. Packet I am sending it not received. Drop the packet. I am unable to receive a packet. Maybe any other reason. I send a packet. So what is your understanding here? UDP don't worry about acknowledgement. It is not worry about acknowledgement. It is just a send a packet. Receiving and it receives or not, we don't know. Even if it is not received, then also we are going on with the packet delivery. It is a very faster, but it is not reliable. Reliability will comes is it's a guarantee of delivery of the packet. Not reliable or unreliable. Not reliable or unreliable. And also called as connection less protocol. It is also called as connection less protocol. Yeah. I have only one question I want to ask, guys. Which one is wired and which one is wireless? Means which one is Wi-Fi? Which one is wired network? My engineering question. Of course, diploma question also. Anyone? Which one is connection oriented? Sorry, connection less. And I'm asking which one is Wi-Fi? Example is Wi-Fi, and which one is wired connection? Sorry, which one is Wi-Fi? Which one is wired connection? No one is talking. Very good. TCP is wired. Which one is Wi-Fi? UDP is Wi-Fi. Okay. No problem. No problem. In engineering, my lecturer also told me like that only. Okay. That's why I'm waiting to you people give at least one person will respond. Okay. Obviously, so when it is comes and question is comes like that, we think this is the wide kind of network and this is the wireless. It means like a Wi-Fi network. Okay. No problem. No. I got it. But it is a completely a wrong concept because I'm using Wi-Fi. I'm using a protocol called HTTPS protocol and which is TCP protocol. Okay, but I'm using Wi-Fi, right? So that is not belongs to any wider wireless. Connection oriented. Connection oriented means when you ask a question to a person or you tell something to a person, the person is responded and given a reply, any reply or in some kind of acknowledgement. So then we understand our message is delivered. Very simple. Uh, you send a message to your friend and you don't know your friend is received or not also. But if you send through the WhatsApp, just WhatsApp thing, check marks are there, double blue check marks. Yes, he seen the message, but he didn't given a reply. right? You can't cheat like I'm very busy. Even I didn't see my mobile phone from last one day, last 2 days. But one thing is important, that is there is a delivery report is there. Very dangerous. Okay, you can't cheat the people. Okay, connection oriented. It means we receive something that message is delivered. That is connection oriented. Very another actual my example is like you went to home very late, father scold, right? Is called, what happened, what, why you are roaming even midnight, no job, nothing, huh? You don't know how to earn a 1 rupee, I'm struggling in my life, like that. So you are become connectionless. Not even a head nodding is also not there. No reply, nothing. Next day father want to do some work with you is there, like go and pay current bill, or pay go and buy some groceries. Okay, so you're asking for money, then you become a connection oriented. So you he given a money and go to shop and buy something. You become a connection oriented. You start asking questions. So what to buy, what are the things required, like that, right? So it's a two-way communication is there. It's a connection oriented. It means one side you are giving a message, but other side no reply. That is a connectionless. It is not a wired or a wireless. Some people just even the lecturers study too much of textbooks, and they want to give an example. They give an example. So in my class both the things are there. Okay, not only I try to give correct information, and also what is wrong information we should check it also. Okay, TCP is a different type of protocols are there, like HTTP, FTP, SMTP. Okay, these protocols, some protocols example I've written only three protocols, there are a lot of protocols are there. So these protocols are an example for TCP type of protocols. It is a TCP type protocols. UDP type protocols also there. Very important protocol is generally we know TFTP. Okay, trivial file transfer protocol, which is used for a yeah, I missed this one. I'll put it TFTP. 69 guys, verify. After long time I remember that one TFTP I'm missing. Okay, 69 as I remember, but verify. Okay, so TFTP protocol is a trivial file transfer protocol for remote configuration protocol or a remote backup using protocol. Okay, SNMP is also there. Yeah, SNMP. Yeah, we have to verify that. DHCP. DHCP is a TCP UDP. Both properties are there for a DHCP. DNS, like this. These are an examples of UDP. Okay, so a protocol can be a TCP or UDP. A protocol can be a both of TCP UDP also possible, but simply it is a type of protocol. TCP type protocol, UDP type protocol only. Okay, this is a big story. And what it will do. So in a transport layer, it's a maintain TCP. Put all the TCP type of protocols into TCP header. Okay, so I'm communicating my session having so many things like, okay, so I'm using a HTTP and SMTP, both protocols I'm using. So it will put a encapsulation like TCP under TCP, these two things. So instead of telling all the protocol things, it keep it in one single only. These are TCP UDP, encapsulate the things. This is called a multiplexing and demultiplexing. Okay, two parts are there in the packet: TCP part, UDP part. All TCP protocols under TCP side, all UDP thing in a UDP box. It's a simple box, you can understand. Actually, you have to go depth of networking, then we can understand. Okay. Another part also there of this one is just I'm giving a name, but windowing. Another one is flow control. Just I will explain what it is. When you send a data, when you send a packet or a data, so whatever it is you use, when you send a data, uh, at when we send packets, packets when you are sending receiver, okay, receiver may not receive all packets at a time. Okay, so we don't send packet by packet, we send a bunch of packets at a time. Okay, 10 packets, 20 packets, 30 packets, bunch of packets, we'll send it and we'll wait for an acknowledgement. Once we receive an acknowledgement for all packets, we'll send a other packets also. Okay, one by one packet will, if you deliver, it will take very long time for communication. So what we will do, we'll send a bunch of packets, but at receiver end it may not receive the packets. Example, I have a think like I have 1 Gbps connection, destination is 100 mbps, 100 mbps, obviously slow connection, right? Obviously slow connection. So you are sending a bunch of packets like 1 GB per second you can able to send. So you send something big packet here, it may not catches all the packets, so some data maybe it will drop out, and it is keep dropping like this. What happen? Data loss will occur again. You have to send it, so your plan for sending data and receiving end should receive very fast way, parallelly it should receive it, but problem is it not able to receive, then automatically drop the packets, you have to send the packet again and again, so it will become totally slow connection. Thing is like speed mismatches kind of stuff. Okay, like you are throwing a balls like a, you take a 10 balls and you can able to throw 10 balls at a time, but other side can able to catch only 5 balls, so 5 balls are will be dropped. So what I will do, so we have to estimate number of packets can receive by receiving and, okay, send packets are doing to it. Okay, simply how much we can able to receive, that much we can able to feed. I plan so many things, it's not happening now. Okay, so guys, it's around 5:30. Anyway, I will finish your OSA layers. Some other part is there, that part I will try to cover on Monday morning. What are the things happen in Monday morning, I will cover up. But either today or tomorrow I will send some material to you, please go through it. So I am going to start virtualization, so read the virtualization also. Okay, and also see the IP address kind of stuff, protocols, names. Okay, that one. And I will ask server related questions also. server and Windows 10. Okay, windowing and flow control is like that. So this is it about your basics of your transport layer. Guys, there is a name called PDU, that is called a packet data unit. Okay, PDU means packet data unit. Normally, people call everything as a packet only, but packet in a OSI layer is only in the one layer only. But data is each layer in the different formats. Normally, application layer normal format only, but in a presentation layer, compressed and encrypted and ASCII format. Okay. Next, in a transport layer, data is not in a same data, right? It is chopped, chopped, cut, chopped, chunk, all are same thing only. Okay, chopped. I use a word cut. Also, we can use a word chop. Chopsticks are there, no? Chop, chop, slice. Okay. So I have a little fear of people take a meaning like, sir, you said cut, but here it is a chopped is there. Okay. So slice, cut, chop. Okay. Now data is not in the same format. So data shape will be changed in each layer. So data in the each layer, the data is in the different formats. In the transport layer, okay. So once it is shaped into the transport layer, what happened? So to your data, a TCP header will added to your EDU. Means what are the things came from the upper layer with the data TCP header will added. TCP header. Okay, header. This we call it as a segment. This total unit. This total unit we call it as a segment. So what are the data from the type of the data from the upper layers and all? So that is a PDU and a TCP header is adding to your packet data unit. The total format of your data we call it as a segment. Okay. So what is this header? TCP header means header contains which protocols you are using, what are their port numbers, what is this segment number, the sequence numbering. Okay, that information stores here. That information, what protocols you are using, TCP type or UDP type, what type of watch protocols, what their port numbers, and also what is the segment name, numbering, sequence like that. Okay, information will be there in this header. This segment will be forward to next layer, which is the next layer, network layer. Now this is a simple one. So network layer is a main layer. Okay, so in a network layer it receives the segment. Okay, and what it will be added, so we'll see that one. So it will add routed protocol information. It is the responsibility of routed protocols and routing protocols. What is this routed protocols? Nothing but your IP address. Nothing but your IP address, IPv4, IPv6. What are the IP address you using? IP address or IPX, IPS, XPX. It's a textbook things only. But generally, routed protocol means your IP address. What is this IP address? Is what it will adding. It add source IP and destination IP address added to our PDU. Our PD name is currently segment. Okay. Source IP address, destination IP address is added to CPU. So that is dealing here. Next, routing protocol. So how to reach the destination? Routing protocols will tell how to reach destination. In generally, computers having a some default route information only. It don't know how to reach the any destination. Just for default means go out and search only. Okay, you don't know the destination. What to do? Go out and search it. So that kind of things are there. But routing protocols also different type of protocols are there. Okay, example RIP version 2 because version 1 is expired. EIGRP OSPF. These three protocols are interior gateway routing protocols. So sorry, IGP protocols. Next type of protocol is EGP protocols. Exterior gateway means our internet is there no. That internet kind of use EGP kind of stuff. What is this EGP? Exterior gateway protocol means outside of autonomous system. BGP, IS, IS. So these are our main two protocols in a exterior. So normally ISIS is there since so many years in the textbooks, but recently they are developing now. Okay, we thought it is a very old one. Now it is removed from it, but it is not a old one. Concept is there, not completely developed. So now it is there developed. Okay, what is this routing protocol? When we use a trace rt command, I reach my destination. How I reach my destination? These routing protocols calculate the path and show the best path to reach the destination. Okay, it will give best path to reach destination. Yeah, yeah, you can write any ways. Okay, so this is a routing protocols. So it add a routed protocol information, routing protocol information. Okay, so this is my network layer. Network layer receive a segment from top layer. So I'm adding source IP. What happened? Source IP and destination IP address to my segment. Okay, so this is my PDU now. My packet data unit is this one. Name of my packet data unit is packet. Okay, name of my packet data unit is packet. So it contains source IP, destination IP. If in case routing information is there, that is also will be added here only. This part we call it as a network header. Network header. This part. Okay. Here also we can put it. This is a transport header. Actually, the name itself is TCP header. Actually, okay. Transport header is a nothing but a TCP header only. but it is a network header means it contains source IP, destination IP, and routing information if it is any routing protocols if you are using. Okay, segment packet data unit is now packet. It is transferred to data link layer. Okay, so what is this data link layer? Data link layer contains two sublayers. One is LLC layer and MAC layer. LLC is first, then only MAC. MAC is near to the physical layer. LLC is near to network layer. Okay, so that is a layer part. LLC, logical link control. LLC means LLC OSI. Okay, logical link control. Because of there is a one more protocol is there. Always I confuse between that one. That is link logical control. Okay, both are look like a same only. So logical link control, what it contains, it maintain your WAN protocols. Okay, the connection between point to point protocols are there. No, that all comes under here only. PPP, HDLC. HDLC is belongs to Cisco only. It is not very much. MPLS is a technology to connect. Nowadays, internet we are using MPLC thing, and of course PPP is also integrated part only. Important one is frame relay. Remember these three things. Okay. Mm, virtual private connections. Uh, PVC, private PVC. Okay, MPLS. These are internet technologies. ATM, asynchronous transfer mode, not anytime machine kind of stuff. Asynchronous transfer mode. Okay. Okay. So these are a main technologies, guys. When you see, so what are the WAN protocols? Are protocols in the LLC layer. So are a layer two protocols. Layer two protocols are MAC address, and these are also there. Okay, remember that one. You know MAC address, right? Media access control. We know this one, media access control. How many bits? 48 bit in a binary representing 12 hexa given by manufacturer. You already have that information earlier. How MAC addresses look like kind of stuff, right? So I'm not going through right again how these things are there. Or you can write 001B. Yeah, it is also called as a physical address. 3 means 6 hexadecimals are completed. So D1, D2, F3. See, it's so simple to write. Example only, right? So who will see? Okay, example of like this. Okay, so even MAC address also there is a lot of theory part is there. Okay, so like this is manufacturer ID. I owe you something is there. This is a sequential number like that. This is a prefix kind of stuff. Okay, it is there. So media access control. It is a physical address, also called as a. Yeah, very good. That is better to recollect. Okay. Next. So in a packet, so we have a data link layer. What it will do? Of course, data header is there. In a data header, it will add source MAC address plus destination MAC address to our PDU. What is the PDU from previous layer to now? From network layer to data link layer. What is the PDU? Packet. Okay. And also it add one more thing called a CRC as a data trailer. So this is my PDU now. The PDU is now is called frame. So this is my PDU now. Okay. So we need. I think lot of people are exhausted. Data header. This is called a data header. But at least one morning I revise. That is almost it killed another half an hour. Half an hour only, not even more than half an hour. This is called a data tail. Head and tail is there, no, like that. Head, tail. Okay, so this is the data header and this is the data tail. Now what is this CRC? I have not having energy to type anything. Copy paste is the best one. So here it is. Cyclic redundancy check. What is this cyclic redundancy check? It is kind of algorithm. See, I'm getting all kind of feelings here. Please. Okay, it is a kind of algorithm and it is used to check errors. It is used to check errors. Okay, not only here, if you have any rar files, I think I don't have any rar files here. Okay, so maybe in Vedic soft folder, I got some rar file here, but that is not actually rar. That is tar file. That is zip file. Okay, I will open this one. So you can see CRC32. It should show some number here. It is not showing that number here because it's a tar file. If you go through the any rar files in your system, I have a lot of rar files in my system, but I am unable to see that one. Yeah, here it is. There is I get a one file. You can see this is ridiculous part. Yeah, no ridiculous thing. Okay, you can see here it is a CRC value. So using this value, it calculate the data. It calculate the data and verify the data whether it is data is good or corrupted. If it is a corrupted, if possible, we can able to recover the data also. If it is completely corrupted, so we cannot do anything. Um, 1 second. Okay, back. Where is this? Yeah. So it verify the data. If data is good, good. If data is corrupted, it can be recoverable, repairable. Then it will repair. Otherwise, it is data is lost. So in a frame, it is added extra. So as a data header, source MAC address, destination MAC address, and data tail CRC value. So it is used to calculate your data using a CRC algorithm with that value, make sure that data is safe, okay, not corrupted. So that's why it is error correction, error checking. This is a error checking. Error correction means sequencing and numbering. This is error correction. This is error checking. Okay. So that's why if you see any some textbooks and all, it shows you do error correction. Okay. What is a error correction means? If packet is dropped, we'll resend the packet and rearrange it back because of segmenting, numbering, and sequencing. Error checking using CRC value, it check your data safe at the destination or not. At the destination, it will check. We generate in a source. The so total PDU now called a frame. This frame sent to guys. Anybody required a 5 minutes break because I also continuously telling a story from last more than 1.5 hour, like 4:20 I started. I didn't given any single break in between. So I think your brain is heated because I need another half an hour to complete this one. Okay. Now one is talking. So this frame from previous layer convert into um bit stream. Okay. Frame converts into, yeah. I'll give you 5 minutes break. So one I will finish in one sentence, two sentence. Okay. Frame convert into bit stream. The bit stream again convert into signals based on what type of media use. Okay. Example: normal Ethernet analysis. Normal analysis like Ethernet. Normal Ethernet communication means it's a wire type, right? So it is a wire type. Electrical signal. Okay. Normal electrical pulses it will generate it. If you are using wireless kind of stuff, means Wi-Fi wireless kind of stuff. Um, Radio signal means it radiate the signal to outside, right? If you are using a fiber optical type of devices, fiber optical wires, light signal. So, so this is complete your OSI layer. So take a 5 minutes break. Just 5 minutes is enough. Come back at it is already 5:50. So 5:55. I need a 15 minutes max. 15-20 minutes is required to compare OSI layer to TCP IP layer, and then also how the packet is encapsulated and de-encapsulated again. Okay, just take a 5 minutes break. I'm back, guys.
This conference will now be recorded.
Only 3 points I want to tell. One is how to compare this OSI layer to TCP IP model. Comparison only. Because of this comparison, lot of people think TCP IP model came from the OSI layer, but now but is not true. Okay, here it is. Application layer. presentation layer, session layer. In the TCP IP layer, it is application layer only. This TCP IP layer also, it is not a layer, it's a protocol suite. Okay, TCP IP is a protocol suite. This model is also called as a DoD model. It is model came from the DoD model. It is a defense model, defense system. Military people, their computers use this model for communication. Next one is transport layer. Same transport only, so there is no change in this one. And network layer. Network layer, here we call it as a internet layer. Next, data link layer and physical layer. So combinedly, both combinedly. So we don't have a space to do that one. So like this is a better one. Both combinedly, data link layer and physical layer. So in a one layer only, network access layer. So this is the comparison between these two things. Next, think like here it is. Actually, this is a better one. So not this one. So this is a better one. So and now I will go through this one only. I will try. Okay, I will type here again. For example, I am taking a PC like a PC1 or a PCA, and my destination is PC2. Okay, so here it is application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. Okay, so here what happens? Um, Physical application layer. So for example, here I send a request, like a HTTP request. Okay, so it's a application. So like a browser or kind of stuff, I send a request. Then in a presentation layer, it compress the data, it is encrypt the data, it convert the data. So that is called encoding and decoding. Okay, this is we call it as a one more point. Here it is. This is we call it as a encoding and decoding. So we encode the data here and encrypt, encode the data, compress the data, and encrypt the data. Next here we start a session. Okay, so that's it. PDU is a PDU up to that one. In a transport layer, we add a transport header, all the things. The data, the PDU become segment. Okay. So sequencing, numbering, and all we are giving here in this one. Here we added a source IP address and destination IP address to our segment. So then my PDU become a packet. Destination, sorry, data link layer. Take the packet and add a source MAC address, destination MAC address to our PDU, and it will add a CRC. This is called a frame. The frame finally converts into bit stream. Bit stream is converted into, for example, I'm using electrical signal wiring connection only. So this is sent to our layer. So again, it is a physical layer. In a physical layer, this electrical signal received convert into bit stream. Okay. In next, data link layer. Data link layer verify CRC whether my data is good or not. So verify CRC and it remove the CRC also, and verify destination MAC address. Okay, verify the destination MAC address and save the source MAC address. So is it belongs to me or not? So destination MAC address must be PC2 destination MAC address. Okay. So then finally I got my PDU, so which is nothing but a packet. Packet is generated from here. So this is finally bitstream convert into frame and given to data link layer. In the frame, it will verify your data with the CRC. If data is good, and it verify the destination MAC address, it is belongs to me. Then finally, it remove all these things, and we got our packet. The packet is transferred to network layer. In network layer, it verifies destination IP, then source IP. Okay, and it remove these things. It become a segment. This segment is transferred to your transport layer. Okay, and it will verify the TCP header, means what are the protocols we are using, and very importantly, the segment having a uh, number and sequencing number is there, no? It sequence the data. And in a session layer, so it accept the session and it create a new session for that one. And here in a presentation layer, so my PD is a PDU, no extra adding things here. All the headers, tails are removed. So in a session layer itself, like session information is there. Here it is, it decode the data, decompress and decrypt. It gives the data. So finally we have our own data. In application layer, it will tell, so what is our request, what protocols you are using. So based on that, it will reply, and it goes on like that. Again it will encode, compress, and encrypt it. So session is already created, like a session is understand. So then it is continue the session, and again it segment the data. It put the sequencing numbering and puts protocols, the TCP thing, adding a source IP, destination IP addresses, adding a source MAC address, destination MAC address, and CRC value, and the bit stream is converted to electrical signal. Again reverse electrical bit stream, like this one only. So it is up and down and up. That's why in some textbooks people will tell from application layer to physical layer, Some people explain from physical layer to application layer. There is a no dangerous things are there. It is simply to understand from one PC to another PC communication. Based on this, we can easily troubleshoot network related things. So how to troubleshoot with the help of OSI layer? Okay, with the help of OSI layer. OSI layer troubleshooting with the help of OSI layer, all the names are same only. For example, my PC. Okay, so my PC not getting internet. My PC is not getting internet. The first thing is verify your physical layer. Are you connected? Is it showing any cross mark? Like I will show you ncpa.cpl. See, can you see here is a cross mark? Actually, I'm using Wi-Fi, but can you see there's a cross mark is there? It means it is disconnected. Either your side or maybe other end of the wire, it is disconnected. So in bottom to top, so you can say verify physical connection. Okay, next. Hmm. Physical connection is good. Still, both systems are not communicating each other. I'm pinging, but both are not communicating each other. Verify IP address is both are in same network or different. In generally, if you have a two PCs are there side by side, like my PC, my desktop is there, so I want to communicate, but they're not communicating each other. Is it a possibility? IP address may be different. IP address may be different, not in a same logical network. Okay, so layer by layer. Of course, transport layer. So in transport is a protocol part, right? So like is firewall on, off, or any exceptions. Any exceptions are required, or better is yellow, deny the protocol kind of stuff. You have to check it. So that is related to transport layer. Okay, so better to check your firewall kind of stuff also, and port speed. Okay, link status. So leave it. We are stick to our thing. Okay, and physical layer also you can see like link status. Okay, this is you have to check it one more. So here it is. Session layer. Session layer, nothing to do. Like session layer, already I given an example. So are you in a same network or a different network? When you switch it to different network, you may not communicate. Okay, are you in same network continuously? Okay. Next, presentation layer. Presentation layer, for example, I use HTTP protocol for a HTTPS um, web website. So then we got a encryption problem. Okay, so like that. So encryption issues also there. So check your protocol exactly. Are you using that one or not? So point is check your protocols and port numbers also. So which port number you are communicating? For example, POP3. 110. Am I given POP3 or not? Earlier? Yeah, I given. So it is mind is like that. Okay. This is regular one. 995 is a over SSL. Okay. So if you want encryption and your server supporting encryption, then use 995. If you are not in encryption mode and your server is also not in encrypted mode, so server not using SSL, 110. Server using SSL, 995. I'm at version 4. 143 is a regular port number, but 993 over SSL. Okay, so like that. So a lot of protocols over SSL, different port numbers are there for an example. Okay. Next, finally, application layer is my destination available. Okay, destination is available or not? We don't know. Service available, destination server. Like I access a web server and it is not providing. Is it a web service we're running? The service web service is running. The question is there, no service availability. You have to verify. Next, what type of application from where? Okay, which application using and support of application. You know, so when I use earlier like VMware SXI, my browser is not working. My browser is in a Google browser. When I put a VMware ESXi, the remote machine IP address here, it is not working. Okay, it's not working. So application and support of application is also when I use Edge browser, it is working. Now it is not working in Edge browser. It is working in Firefox. The because Firefox is a keep updates always. Google Chrome updates are available, but it won't update automatically. It won't ask you to update again. You have to update manually. But Firefox is an automatic update. It will update. So it is supporting in a Firefox. It means some applications support certain kind of client applications. Sometimes it won't support, so check the which application you are using, is it supporting your application or not. So that is very important. So this is a layer wise troubleshooting. So if you got any issue, depends upon the issue, so we can easily understand from the YSA layer. Okay, so your troubleshooting part 1 is completed. See. Okay, yeah, so only one thing is required. It is there is a hardware layers like layer 1, right? We know layer 1 is nothing but a physical layer. Example device is hub. Layer 2 device, which is data link layer. So example is switch is a layer 2 device. Layer 3 router. Example is sorry. Network layer. Router is a example device. Okay, so you guys understand why router is a network layer 3 device, because router can understand IP address and routing protocols also. So network layer support your IP address, routed protocol and routing protocol also. So MAC address is available at a data link layer. So that is switches can understand MAC addresses. In the packet it understand the MAC addresses. Physical layer is direct connectivity, so that's why the hub is a direct example for a physical layer, because it don't understand MAC address and all. simply it receive a electrical signal, it forward the electrical signal again. Next, lot of people, even after selection also, they call me, sir, switch is layer 1, sorry, layer 2 or layer 3. The people are asking like this. Of course, layer switch is a layer 2 only. So switch is a layer 2 only. But there is a switch called a layer 3 switches also there. Okay. So normally switch consider as a layer 2 device only. Layer 3 device is not a exactly switch, it is like it is a kind of a router type. Okay. It is like bridge router is a router. Sorry. So it is a switch router type. It means this function as switch and as well as router 2. So remember that points. Okay. Yeah, this is enough for you, and it is already 6:20. Meet you on Monday, guys. We'll continue. We'll see on Monday. But meanwhile, study whatever I send it. I will send this one also, and I will send thing. So read all things about your networking and Windows 10 and your server also. Because next classes, my class is never be a straight. So lot of people said to me, so go for straight, but my class is never to be a straight one. So I'll mix up the thing and